Good morning to all. Today we are going to discuss the third unit, second concept, nothing but nice and ugly domains. So in that first we are going to discuss what is mean by the nice and ugly domains. In that first point is where do these domains come from? These nice and ugly domains, where do they come from? So they are come from the domains are and will be defined by an imperfect iterative process aimed at achieving satisfaction. So these domains are come from by defining an imperfect iteration process and aimed at achieving satisfactions. So, so to achieve satisfactions by providing imperfect iteration process. So due to these types of things, we are getting these nice and ugly domains. If they are correct, they are comes under nice domains. If they are not defined properly, incomplete things, they are comes under ugly domains. Then specified versus implementation domains. So implemented domains can be complete or consistent. Then specified domains can be incomplete and inconsistent. So some of the domains may be implemented domains and some of the domains may be specified. If the implemented domains means they are complete domains and consistent domains. If the specified domains means they are incomplete and inconsistent domains. Now we are entering into the nice domains concept. In the nice domains, some important properties of nice domains are so they are linear. Nice domains are always linear, they are complete, they are systematic, and they are orthogonal and consistently closed, simply connected, and convex. So these are all comes under the properties of nice domains. So to the extent that domains have these properties, domain testing is easy as test gets. So if the domain may have these properties, these six properties are available, then those domains are very easy to test also. So the bug frequency is lesser for nice domains than for ugly domains. So compare with the ugly domains, nice domains, bug frequency is also less. Now we are going to discuss those six properties one by one. In that, the first one is linear and non-linear boundaries. So linear boundaries in nice domain boundaries are defined by linear inequalities or equations. So they are linear equations. The impact on test instance from the fact that it takes only 2 points to determine it is a straight line, and if you take 3 points to determine the test boundaries, then it is a plane, and generally it takes n plus 1 points to determine it is n dimensional hyperplanes. So to determine the boundaries, if you take only 2 points, it is a straight line, and if you take 3 points, it is a plane, and if you take n plus 1 points to determine it is n dimensional hyperplanes. Then in practice, more than 99.999% of all boundary predicates are either linear or can be linearized by simple variable transformations. In boundaries, in domain testing, all the boundaries may be linear. If they are not linear also, we are trying to convert them or transferring them into linear by transforming some simple variables. So this is the concept of linear and non-linear boundaries. Then if you come to complete boundaries, so complete boundaries means the boundaries are completely filled. Such type of boundaries are complete boundaries. So complete boundaries are complete in that they span the number space from plus to minus infinity in all dimensions. In all dimensional manner, all the boundaries are completely filled. Such type of boundaries are comes under complete boundaries. Then the next one, systematic boundaries. Systematic boundaries means it must follow a systematic procedure to bound the variables in the domains. That is nothing but systematic boundaries. When you come by systematic boundaries means that boundary inequality is related by a simple function such as constant. They are bounded in a systematic manner. For example, for f of x greater than or equal to k, or f of 1 of x greater than or equal to g of x, all in this manner, in a systematic manner, the concept must be defined. For that, a good example means how the spokes in a wheel. So, for example, if you take a cycle wheel or a bike wheel, how the forks are arranged in the wheel in a systematic manner. So, that is a good example for systematic boundaries. Then if you come to orthogonal boundaries, so orthogonal boundaries means if two boundaries set U and V are said to be orthogonal, if two boundaries are there, they are both orthogonal means how they are orthogonal means if every inequality in V is perpendicular to every inequality in U. So U must be V is perpendicular to U, then only U and V may said to be orthogonal. Then if two boundaries sets are orthogonal, then they can be tested independently. If the boundaries are orthogonal, you may test them in independent manner. So this is the concept of orthogonal boundaries. Then closure consistency. The next property is closure consistency. Closure consistencies are consistent and systematic. The boundary closures are always consistent and systematic. So consistent closure means that there is a simple pattern to the closure. Then, for example, using the same relational operator for all boundaries of a set of parallel boundaries. So, by using the same relational operator for all boundaries of a set of parallel boundaries, then those boundaries are comes under closure consistent. This is the one of the property of nice domains. Then convex. So this is one of the property. If convex means if you can take two arbitrary points on any two different boundaries, join them by a line, and all points on that line lies within the figure. So if you take any two arbitrary points and two different boundaries, then join those two points by a line, and all the points in that line lies within the figure. So in this manner, if you define any boundaries, then it is a convex property, and it is one of the property for nice domains also. Nice domains are convex, dirty domains are not. So reliability of domain testing breaks down for domains with concavities. So always, if it is convex, then they are nice domains. If they are not nice domains, then concavity will be arised. So this is one of the property of nice domains. Then another one is simply connected. So nice domains are simply connected. That is, they are in one piece rather than pieces all over the place interspread with other domains. So they are simply connected. They are one piece rather than pieces of all the places spread in the other domains. So domains. So if it is a nice domain, so what are the points are there? They can simply connected to each other. They are in one place. They are not spread out throughout the domains. So this is the concept of simply connected. So these are the properties of nice domains. If these properties are satisfied, then they are those domains are comes under nice domains. Then what is meant by ugly domains? If these properties are not satisfied, then that means the boundaries may have the problems or holes in that. Then such domains are comes under ugly domains. Some domains are born ugly and uglified by bad specifications. So some domains at the born itself, when newly created, they are ugly. But some domains may be created uglified by due to bad specifications. Every specification of ugly domain by programmers can be either good or bad. So whatever the specifications developed by the programmers may be either good or bad. So ambiguities and contradictions in ugly domains. Domain ambiguities are holes in the input space. So I already said if the domain may have holes, that means space, empty space are there, they are comes under ambiguities. And those domains are ugly domains. The holes may lie within the domain or in cracks between the domains. So the holes may be lies between the within the domain or cracks between the domains, whatever it may be. They create ambiguities and they comes under ugly domains. Two kinds of contradictions are there: overlapped domain specification and overlapped closure specifications. So there are two types of contradictions are there: overlap, domain specification, overlap, closure specifications. These are the two different types of contradictions are possible. Then the next one is simplifying the topology. The programmers and testers reaction to complex domains is same as simplified. There are three generic cases. One is concavities, holes, and disconnected pieces. So in nice domains, it is convex. If the domains are concave, it comes under ugly domains. In nice domains, they are complete. But if the domain may contain holes, they are comes under ugly domains. In nice domains, the pieces are simply connected, but here they are disconnected. So such type of concepts are all comes under ugly domains. So these are nothing but simply simplified topologies of ugly domains. In the domain we have holes. The domains are not completed. They are not connected. So these types of concepts are all comes under ugly domains. So in today video we discuss nice domains and ugly domains. Nice domains may contain six properties, and ugly domains, if they are not followed, what are the concepts are not followed in the nice domains, they are all comes under ugly domains. Thank you.